Hello everyone, I'm Dr. Steve Warner, and today I'd like to do some basic algebra, and I'm going to go over how to solve simple algebraic equations, both informally and formally. Let's go right to a simple example. X plus 3 equals 8. What this question is asking is, what do you need to add to 3 to get 8? Well, you add 5 to 3 to get 8. So since 5 plus 3 is 8, the answer is simply 5. I call the technique I just used solving this equation informally. On standardized tests like the ACT, it's nice to try and get in the habit of solving equations informally to save time. Let's also go through the formal solution. To solve this equation formally, we would subtract 3 from each side of the equation to get x equals 5 as before. Okay, let's look at another example. 5x equals 30. 5 times what is 30? Well, 5 times 6 is 30, so that the answer is 6. Formally, we could solve this equation by dividing each side by 5 to get x equals 6 as before. Let's look at an equation that's just a little bit more complicated. 5x plus 3 equals 48. We can still do this informally, but it requires 2 steps. Okay, so first we could ask, what plus 3 is 48? Well, 45 plus 3 is 48. So 5x is 45. Well, 5 times what is 45? 5 times 9 is 45. So the answer is 9. Okay, I did that all in my head. If that went too quick for you, then pay careful attention to the more formal solution. We start by subtracting 3 from each side of this equation to get 5x equals 45. And then we divide each side by 5 to get, once again, x equals 9. Okay, here's an example that involves division. X over 12 equals 2. So the question is, what divided by 12 is equal to 2? Well, 24 divided by 12 is equal to 2. So the answer is 24. Formally, we could solve this equation by multiplying each side of the equation by 12. When you multiply on the left by 12, the 12s just cancel and you get x. And on the right, 2 times 12 is equal to 24. Some people like to change this equation slightly by putting the 2 over a 1 and using cross multiplication. That's okay too. Let's look at a slightly more complicated example. 2x minus 3 divided by 5 is equal to 2. Okay, so what divided by 5 is 2? Well, 10 divided by 5 is 2. What minus 3 is equal to 10? 13 minus 3 is equal to 10. Finally, 2 times what is equal to 13? Well, 2 times 13 halves is equal to 13. Or as a decimal, 6.5. Okay, let's go through the formal solution now. I'm going to multiply each side of the equation by 5 to get 2x minus 3 is equal to 10. And then I'm going to add 3 to each side of this equation to get 2x equals 13. And finally, I'll divide each side of this equation by 2 to get x is equal to 13 halves, or 6.5 as before. Okay, how about this example? 5 times x minus 7 is equal to 40. First, let's do it informally. 5 times what is 40? Well, 5 times 8 is 40. What minus 7 is 8? Well, 15 minus 7 is 8. So the answer is 15. Formally, we could solve this by first dividing each side of this equation by 5 to get x minus 7 equals 8, and then adding 7 to each side of this equation to get x equals 15 as before. Here's an algebraic equation involving exponentiation. We can do this the same way. 2 to the what is equal to 8? Well, 2 to the third power is equal to 8 because 2 times 2 times 2 is 8, so that x is equal to 3. Formally, we could solve this by rewriting 8 as 2 to the third. Now that the bases are the same, so are the exponents, and we get x equals 3 as before. Here's a slightly more complicated algebraic equation involving exponentiation. 5 to the x plus 1 equals 125. So let's do it informally first. 5 to the what is 125? Well, 5 to the third is 125. Now, what plus 1 is 3? Well, 2 plus 1 is 3, so x is equal to 2. Formally, we could rewrite 125 as 5 to the third. Now that the bases are the same, so are the exponents, so x plus 1 is equal to 3. And we subtract 1 from each side of this equation to get x equals 2 as before. Okay, let's look at an equation involving absolute value. Informally, we could start by saying, what minus 4 is equal to 9? Well, 13 minus 4 is equal to 9. So z equals 13 is a possible solution. But z equals 13 is not an answer choice. Don't be tricked and pick negative 13 as the answer. That is not correct. Now remember that the absolute value of z minus 4 equal to 9 is actually two equations. Z minus 4 could be 9, but z minus 4 could also be negative 9. So since this one didn't work, this is the one we want to look at. What minus 4 is negative 9? Well, negative 5 minus 4 is negative 9. So the answer is choice B. Again, we could do this formally. And I'll just do the second one by adding 4 to each side of this equation to get z equals negative 5.